Hey, Dr. Tran, how you doing?
Hey Chris, how's it going? Good, good.
How you
How are you?
feeling?
Feel okay. I mean, symptoms are mostly gone at this point. I'm just kind of waiting for a negative, hopefully a negative test. But yeah, I
Yeah.
was kind of sick over the weekend, so I just
Oh,
you know
yeah,
didn't want an emergency on the first week of class because I think that's the not a great way to start the semester.
yeah, I understand. I hope you feel better.
Thank you, thank you.
Yeah.
How was your summer?
It was all right. I gotta try to enjoy my free time before I head back to a full schedule.
Mhm.
But yeah, it's been all right. Just trying to figure out some personal projects. I ended up getting a 3D printer, just
Nice,
familiarizing myself, building some stuff and whatnot.
nice, nice.
How about yourself? How you been? How's your summer?
Yeah, it was good. Yeah, it was yeah, I mean just restful, doing a little bit of prep. But yeah, it was business as usual summer, but
Mhm.
it was good. It was
That's good.
simultaneously like really long, like it felt like spring semester was so long ago, but
Yeah.
also really short as in I'm not ready to start yet.
Yeah, I feel you. I was in that limbo of wanting to do nothing, but at the same time wanting to do something
Oh
during
yeah.
my summer.
Yeah. I know the feeling.
Yeah.
Hello, Professor.
Hey Josh, how's it going?
It's going good. Probably jumping the gun right here, but I'm on the wait list. Do you think that there's going to be enough room? I believe I'm number 5 on the wait list.
Okay. Let me see what the enrollment for this class is, because for one of my other classes, I have 40 students already. But I think for this class, it was less. Let me see. You guys can peek behind the curtain a little bit here. So so usually, especially for this class, I try to be, I try to accommodate as many people from the wait list as possible. Um, but lately it's my workload's been kind of a lot, and so last semester it got kind of bad. But looks like there's one spot open right now. Oh, but there's 6 people on the wait list. If the total amount of students remains under 40, then that's a good number for me. And so as of right now, there's 34 people that are officially enrolled, and then 6 of you waiting. And so at this point, everyone on the wait list will be able to get in.
Awesome. Okay, thank you.
Yep. Mm-hmm.
Hey, Dr. Tran.
Hey, Steven, how's it going?
Good, good, sir. How are you feeling?
I feel okay. Yeah, I think
Good.
a lot of the symptoms are kind of passed, so I'm kind of just waiting for the results of the tests. But yeah, this weekend I was just feeling sick, and so I just wanted to be safe. I think you can never be too cautious with these things, so I thought I'd stay
Yeah,
home. Yeah, yesterday I was feeling it a little bit still, but today I definitely feel a lot better than before.
that's good. Definitely good.
How are you doing?
I can't complain. It's been, normal first week of school, so we've been good. Had a no school during the summer, so I got lucky enough to hang out at home and be lazy and you know not have to do much.
Nice.
which is kind of like a blessing and a curse at the same time, you know, like.
No, I feel you. Yeah, Chris and I were just talking that it's the summer. It's you want to do nothing, but you also want to be productive at the same time, and it's kind of a weird limbo. But resting and taking care of yourself and getting healthy. Those are always going to be important. So yeah, glad you're able to rest a little bit.
Yeah.
I got a little hobby over the summer trying to work on some models.
Nice. What is that?
Zaco Gundam.
Oh, nice. That's awesome. You 3D print those parts, or did you, or was that a kit that you bought?
This is a kit, but I actually 3D printed the base to hold it.
Nice.
And it came out really well just to hold the model.
Nice.
So yeah, I don't gotta spend money on bases anymore.
Nice. Yeah, those things can get expensive. Like I have a friend that's into model Gundams, and it's pricey. It's crazy.
Oh, definitely. I got a couple. I got the big grade, the master grade, so they're usually like 10 or 12 inches big. But yeah, I have one that I have just on the back burner. I've been meaning to work on, but I've just been feeling lazy because I'm gonna dedicate so much time to it. I'm like, I don't want to work on that right now.
You want to make sure you set aside all the time you need.
Yeah. I'll probably build it once I graduate as a nice little victory lap.
Nice.
Hi, Dr. Sharon.
Hey, how's it going?
Good, thank you. Hope you're doing better.
Oh, thank you. Yeah, I'm feeling better. Yeah, just trying to be cautious. So I got tested, and so even though I'm feeling better, I said might as well just wait for the test to come back before I do anything.
Yeah.
All right, it's 5:30, so let's go ahead and get started. All right, good afternoon, or I guess it's good evening, everyone. So first of all, let me say thank you. I know it was kind of a last minute change to go virtual, and I know this class is planned for in person, but I appreciate you guys being flexible with this. Just to give a little information, so over the weekend I started feeling a little bit sick with some mild COVID symptoms. So I had a fever and a cough, and so I thought I'd just be safe and just, say, we have these tools to go virtual anyway, so let's use them to keep everyone safe, because I don't want to lecture in front of you guys and like get my spit all over the place and potentially infect you with COVID and have that be our first experience. That's never a good way to start the semester. So and so I appreciate you guys being here virtually and being flexible with this. And as soon as I get a negative test, we'll be back in the classroom. Hopefully before Thursday, because Thursday we do have an ANSYS activity planned. So it'll be nice to have the lab computers for that. Okay. All right. So with that, I want to say welcome. So and so probably you guys have had other classes this semester, but already. But welcome to the fall semester for 2021. This is EGME 410, Introduction to Finite Element Analysis. Right. So this is the undergraduate version of our finite element class. It's the first time in a while this class has been offered in the fall. And so just a little bit of background. So traditionally this class is only offered in the spring. But what I've seen in the past is that a lot of you guys, or a lot of you all like to, or you want to use ANSYS for your student projects that you work on throughout the year. And so by the time that you learn it in the spring semester, it's kind of too late, to really use it for anything useful. So, I had requested to have this class offered in the fall. And so, I'm really happy you guys are here. I'm really happy there seems to be a lot of interest, because it's, hopefully this is going to be used for, for your projects. Okay. All right. So for the plan for today, I don't want to do, first day. I know everyone's still trying to get back in the swing of things. I know I am too. And so we're not going to be doing anything intense today, right? So we're not going to be opening up the program or anything. And so my goal for today is just to introduce the course, just tell a little bit about, what my goals for this course is and what you can expect to learn, and also to go over the syllabus. Okay. All right. And so let's go and get started. Actually, before we start, are there any questions I can answer? Before we launch into it. Right. If you guys, I know probably you guys are used to Zoom at this point, but if you ever have any questions, feel free to turn on your mic and ask that way, or you can put the question in the chat, and so I can view the chat from here too, and either whichever way is comfortable for you. Okay. All right. So away we go. Okay. So let me start by introducing myself. I always forget to do this, but my name is Professor Justin Tran. You can call me whatever you want. Honestly, it doesn't matter to me. I've been telling everyone that I've grown up in the era of online video games, so I've been called all manner of things by probably kids that probably shouldn't be using those kinds of words. So whatever you feel comfortable with, I'm going to feel comfortable with. So whether it be Professor, whether it be Dr. Tran, Justin, you can call me Dick Face if you want, but no one's taken me up on that yet. But it's out there, right?
Oh, it has to have a doctor in front of that.
Dr. Dick Face, I like that. Yeah, feel free to do that. So I'm not particular on how you call me, but as long as I can tell that you're talking to me, that's the only thing I really care about. Okay. All right. So my office is in the CS building. I'm on the 5th floor, and so I'm in CS 526. And so it's a little bit out of the way, I know, but it's so whenever people come up there to visit me, I always appreciate it. My email is right there on the screen. It's called justran@fullerton.edu. And so that's pretty easy to remember, because it looks like I just ran something, like I just ran a mile, right? So that's so if you ever have any questions, definitely feel free to email me. Okay. I grew up around here, so I grew up in Cypress, which is not too far. It's about 7 or 8 miles west of campus, and so I know Cal State Fullerton really well. I know this area really well, just because this is where I grew up. Okay. There's all my background. So I've done all my schooling in California, and I've done all of it's been in mechanical engineering. And in terms of research interests, I'm really interested in applications of engineering tools for studying heart and blood disease, and also STEM education. So how can we teach engineering better? And so I'm always interested in doing that. Okay. All right, and so let's talk about learning objectives. And so if you've had me before, you know that I love these things. And so you can expect to have a list of learning objectives before every class. And what these are basically checkpoints or contracts that I'm writing to you guys to basically say that after this class you should be able to do all the tasks that I have here. Okay. And so for today we have 3 learning objectives. And so the first one is to describe the use and utility of finite elements in engineering work. Second is to describe the steps of the finite element process. And finally, we're going to go over the syllabus. Okay. And so I always tell people to write these down at the beginning of the semester, at the beginning of the class. And then when we're done with class, go back to the learning objectives and use that to test your knowledge to see, can I actually do all these things? Can I actually accomplish all the objectives from today? And if the answer is yes, then you got everything from the lecture that I wanted you to get. But if no, then maybe we didn't finish. But also maybe it's maybe a good idea. Maybe talk to me and see clear up any points of confusion. All right, and so finite elements, and so I know a lot of you are coming into this class and you already know a little bit about it, but I think just so we're all on the same page, let's go over kind of a basic definition. Okay. And so finite elements, finite element analysis, it's at its core, it's a numerical technique for solving differential equations on arbitrary geometries. Okay. And so what that means is that we're going to use computers to perform a bunch of calculations that at speeds that far exceed human capabilities. Okay. Because normally when you try to solve engineering problems by hand, you're trying to solve a governing equation, you can only really do it in the simplest of cases, like a very simple geometry, very simple case, right? But if you want to do anything practical, like anything with a non-trivial geometry, you have to really rely on simulations to do this, right? And that's where finite elements come in. And as computers get more and more powerful, it's really becoming a workforce for the engineering community. Okay, because what it does is it allows design and analysis of really complex systems, systems with complex geometries, complex loadings, complex boundary conditions that would normally be impossible. Okay, and the reality is, I think, as a student, I remember, you take like a statics class, you take like a fluids class, you think, a lot of situations might be really simple, like a simple beam or a simple pipe, right? But the reality is that that's just not true, right? Because if real engineering systems were simple enough as like pipe flow or beams, a lot of people would lose their jobs, honestly. And so, a lot of practical engineering systems fall into this category where they have very complex conditions that you really need simulations to really predict. All right, so very quickly, let's go over kind of the types of analysis. Okay, and by analysis, what I mean by that is you have an engineering system, like you have a problem that you have in front of you, and there's some information that you want to find out about that system. Okay, and so some examples of this might be like you have a structure, right? You have like a building, and you want to find out if it can sustain the weight of all the people in the building. Okay, so that's a type of engineering analysis that I'm talking about. Right? And so the first way that you can approach this analysis is analytical. Okay, and so these are the pen and paper calculations that you probably know from your previous classes. And so these are usually great when you can do them because they lead to a solution that's pretty quick and pretty inexpensive. But you can only do these for the simplest of problems, kind of like what we talked about before, right? And so if you only have just a straight pipe, or maybe just have a straight beam with uniform cross section with very simple loading, right? So analytical methods, I think they're great. They're great educational tools in that they get you to really understand the concepts behind it, but it's not really practical to apply these to a lot of really practical problems unless you really vastly simplify the geometry. Okay. And so the second method that's out there is called experimental. Okay. And so experimental methods really don't involve any equation solving at all. Really, the core of experiments is, if we want to find something out, let's just run an experiment to collect the data, right? And so an example I gave, in a previous class is, maybe you want to find out if your car can survive running into a tree, right? And so the best way to find that out is to take your car and run it into a tree, right? And that would be an experiment. And if your car survived or not, then, that's your engineering analysis, okay? And so the nice thing about experiments is that no one's gonna dispute you, right? No one's gonna call you fake news or anything like that, right? So if you run your car into a tree and it survives and people see it, no one's gonna dispute that. It actually happened, right? And so the data that you get from experiments is always gonna be, I call it like the gold standard. So it's always gonna be great, okay? The downside to experiments is that it can be really costly and really time consuming, right? And so if you really want to find out if your car can survive running into a tree, there's probably better ways of doing it than actually wrecking your car, because that's then you have to buy another car, which is not fun to do. Okay? And so the third type of analysis that's out there is called computational. Okay, And so in this description here, I say that it's similar to analytical in that, the core of computational methods is that we're solving equations, we're solving some math. But, instead of us doing the math, we're making the computer doing it, okay? And this is great because computers are really good at doing calculations. Okay? And, the nice thing about computational is it kind of fills a niche in between analytical methods and experimentals, where computational methods, you can handle really complex situations really inexpensively, right? And without having to destroy anything. But the downside to computational is that it can be really tricky to set up, right? And I would even go as far to say is that it's deceivingly tricky to set up, right? Because I think what a lot of people do is that they download like a finite element software, they download ANSYS, and they try to, they take, the simple tutorials out there and they try to apply that to a practical problem. And they get results that they think it looks good. They think it looks reasonable, but it's actually complete garbage because the setup just wasn't correct. Okay, and so there's a lot of ways. I like to say that when you're dealing with finite elements, there's a lot of ways that you can mess it up, and a lot of ways that you can get wrong results. But it might not be immediately clear if you're not really trained in it, and that's what this class is all about, right? And so in this class, my goal is to basically teach you guys, how to set up these computational problems, how to set up finite elements in a way that, you do get results that are reliable, that can lead to good engineering design. Okay. All right, so let's go over just some quick examples of kind of the differences of what you can do with analytical methods versus computations. Okay, and so here I have a very simple beam, right? So you've probably seen problems like this in like a statics class or strength of materials class. And so, you can take this beam and you can solve the equations for the stress and for the deflection in the beam, right? But if you want to do something that's more practical, like maybe say, you want to find out the stresses in this beam in this big building, right? It's, this is something that's way too complex to do with pen and paper calculations. And so you need to really rely on computers and finite elements to kind of get the job done for you, right? All right, so now let's do an example for heat transfer, right? And so heat transfer, maybe I don't know if you guys have taken 407 or not. It's not a requirement for this class, but when you take 407, you'll be able to solve situations like this, where you can solve for you can see how the temperature varies in a very simple situation like this, where you just have a rectangle, a rectangular wall with a uniform area and temperatures on both sides, right? And so for a very simple case like this, you can solve it using analytical methods or pen and paper. But if you want to do something more complex, like say, you want to see what the temperature in a turbine is as hot gas flows over it, you need to use computation to do this, because this geometry and these conditions are way too complex to do, with pencil and paper. Okay. And one last, very simple case, just because I myself am a fluid mechanics guy. And so, if you have a simple pipe flow like this, you can solve this by solving Navier-Stokes by hand, right? But if you have a more complex situation where, let's say that you want to solve for, the velocity distribution for the blood inside your body, right? You can see this geometry here is a lot more complex, where you have kind of a bifurcation going on here. You have this injector pump-ish thing coming on, and lots of very complex flow patterns. This would be almost impossible to do by hand. And so you would have to do this with computations, which is exactly what's been done here. Okay. All right, and so now I want to turn it over to you guys, because I know a lot of you are coming into this class, kind of with the goal of learning finite elements to apply it to a project, whether it be your senior design project. I know that's kind of starting up really soon, or maybe you're on one of the, student projects here, like Baja or like Formula. And so I want to hear what you guys are planning to use finite elements for, or what you guys are interested in learning. And so you can go ahead and put in the chat or turn on your mic, or whatever you feel most comfortable with.
Well, I'm on Titan Rockets senior design, and I'm definitely interested in using FEM for the analysis on the fins of my rocket, particularly because they're well exposed, they're going to have flow around it, but looking at what kind of forces that it can endure, both frictionally, but more so like shear stress on that, to find out where they could potentially break or snap or crack or cause my rocket to spear somebody's car, which has been known to happen. So yeah, trying to do it on the structural airframe of the rocket itself would be one thing that I'd be interested in trying to do with, amongst other things, bulkheads that go between different sections and that kind of stuff.
Nice. Yes. So thanks, Stephen, and that validates my decision to put this course in the fall semester, because now you can do that, right? And so now you'll have all the tools and with Finite Elements to work on that this semester, and maybe incorporate some of this into your design for next semester. So yeah, thank you for sharing. Anybody else? Oh, I see one in the chat. Okay. All right, so Nicholas. All right, so Nicholas is in formula on suspension, and so he's interested in looking at the stress on the rockers and the pistons, and how much material can he remove and where to remove it from to reduce weight. That's a great application. And so what Nicholas is talking about there is design optimization, right? And so a lot of times, as a lot of you that are on student projects know, that you have parts that you're machining or parts that you're working on for your project, and you want to see whether you can remove the weight or move some material from it or move some weight and still have it perform all of its duties, right? And so and I guess in the case for Nicholas's case, for the rockers and pistons, if he can remove some material and have it still work well and still not break, that's a big win, because any weight that you remove from a vehicle is going to lead to a significant reduction in and the amount of energy that it needs to produce it, and it'll result in a big boost of efficiency. So yeah, we're going to do optimization is one thing we're going to be working on probably closer to the end of the semester, just because it's a little bit more advanced, but definitely really interesting topic. Yeah. All right, anybody else?
Yeah, sure, I'll go. Similar situation, just as Stephen. I am also part of the Titan rocket. I am a member of the avionics sub-team, and my task is to basically come up with the brain of the rocket. So I have a couple of ideas on how to design the avionics bay, the enclosure for the circuitry, and yeah, I was just thinking before then, like how much stress the material itself will be able to withstand. So FEA will definitely be very useful to at least find that sweet spot to determine the type of material or how strong it can hold and all sorts of stuff. Yeah, no, that's a great application too. Yeah, and finding out stress distributions is I think one of the really really nice features of FEA, because that's one thing that's really hard to do with pen and paper calculations or with experiments. And so the nice thing with finite elements is you get a really beautiful picture of what the stress distribution looks like in these parts. So yeah, definitely a great application. All right, so anyone else want to share one more before we move on?
I have a question.
Sure. Yep.
Are we able to create something on SolidWorks and then maybe bring it to you and see just the parts of the model that we create on SolidWorks have the biggest stress and where they're able to fail? Yeah, I mean, you'll be learning how to do that exactly in this class. And so that's one of the really nice things about ANSYS, is that it interfaces with SolidWorks really well. Because traditionally, I think even professionally in a lot of companies, they'll produce the CAD geometry in some kind of other software, whether it be SolidWorks or Catia. It's just a lot more convenient to use those softwares to produce the CAD, and so ANSYS knows this, and so ANSYS basically provides a way where you would import SolidWorks models, import SolidWorks assemblies into ANSYS and perform finite element simulations on there. And so yeah, that's a big thing we're going to learn in this class for sure. Yeah. All right. So thank you everyone for sharing. So yeah, definitely a lot of really cool applications and a lot of things you can do with finite elements that we're going to learn in this class. Okay, and so the next thing I want to go over is what I like to call the finite element process, right? And so this is kind of just a very quick kind of an overview of it. And we'll be doing this kind of more concretely on Thursday when we actually open up the software. But I want to just give you guys a flavor of how you would actually apply finite elements to a problem. Okay, because this process here, even though it's very general, this process is applied to basically any time you want to run finite elements. Okay, all right. So the first step in this process is to define the geometry. Okay, and so the first step, for any even a pen and paper calculation, right, you need to define
what the geometry looks like in your situation. Okay, and actually, as Josh mentioned just now, probably the most common way that finite elements is used in practice is you start with some kind of CAD geometry, right? And so commonly this is produced in like SolidWorks, just because SolidWorks is really robust, it works really well. But actually, ANSYS has its own CAD software built into it as well. And so, if your goal is just to perform just a finite element analysis, you can actually produce the CAD model all within ANSYS, and so you don't have to switch between the programs. But a lot of times, if you're working with on a bigger project, we have SolidWorks models for all the different parts that you have, and so it's just more convenient to work in SolidWorks because the SolidWorks model is used for a lot of other things. Okay, and so that's always the first step, and so you have to get some kind of geometry. Okay. And so in a lot of ways, you can think of finite elements as kind of a sequel to all of your CAD classes, because in previously in all your previous classes, you've learned how to produce the CAD, right? You produce the geometry. Now with this class, you're going to be able to actually do something with it digitally. Okay? All right. So the next step in the process is to specify the material properties. Okay. And so now that you have your geometry, you have to specify what your geometry is made of, right? And so that's what I call material properties, right? And so there's a lot of built-in materials that are in these programs. And so if your part is made of something simple like aluminum, or if it's made of steel or copper, those materials will be there. Okay. And what you're doing basically when you assign these material properties is you're defining a lot of its numerical properties. So things like Young's modulus, things like density, things like Poisson's ratio, right? And so if you remember from your strength of materials class, these parameters, they have a strong impact on the results. Okay. And the same thing is true for finite elements, right? And so depending on what material that you make your device out of, your geometry, it's going to have a strong effect on how it responds to external stresses. Okay. And so I have the structural parameters here, but if you want to run a thermal simulation, you're going to need things like thermal conductivity, things like heat capacity, things like that. All right. And material properties can range from incredibly simple, and so you might have like a homogeneous isotropic material where you only need maybe 3 or 4 things to define, or you might have a very complex material, right? You might have like a composite, or you might have something made of wood, right? And so those materials are a little bit more complex, and you need to be a little bit more careful in how you specify those properties. Okay? But that's something that we're going to go over, a lot this semester about, how to specify these material properties, for these kinds of applications. Okay. All right, and so the next step is to discretize, or in other words, to mesh. And so this will be a big focus on this semester, because I think this is the part that I think a lot of people get hung up on, and this is the place where a lot of people make mistakes in their finite elements too. Okay, and so in order to run a finite element simulation, you need to break up your geometry into a lot of simpler shapes. Okay, because ultimately what the computer wants to do is that it wants to solve the governing differential equations on your geometry, and that's really hard to do when your geometry is a generic arbitrary geometry, right? And so in order to make this job simpler, it has to basically pixelate it. Okay, and so it's not really pixelating it, but that's kind of the word that I like to use, because I think that's kind of the thing that people think of. Okay, and so on the right here, you can see that we have this kind of flange type geometry here, and we've broken it up into a lot of really simple shapes, right? And so if you look at kind of the individual shapes here, you can see that they're all boxes, right? And so they're basically this like a six-sided hexahedron. Okay, and so the most common name for this step is called meshing, and that's kind of the term that I'll use for that. Okay. And each individual shape here that we broke it into is an element, and that's where the name finite element comes from, right? And so we're going to spend a lot of time on this, and so I'm not going to say too much on it here, but there's a lot of things about the mesh and how you break up the geometry and how that affects your results that we're going to go into a lot this semester. Okay, and so I will say that this is the thing that people will judge you on, and so if you go out into the workforce and you do finite elements, the way that people are going to judge your finite elements, the first thing they're going to look at is your mesh, and whether you have a good mesh or if you have a bad mesh, right? And so, what constitutes a good mesh versus a bad mesh, we're going to go through a lot of that this semester. All right, and so the next step is to apply the boundary conditions. And so boundary conditions, these are basically how your part or how your geometry interacts with the outside, all the other stuff that's outside of the geometry, okay? And so the most common boundary conditions that we're going to apply are things like loads and constraints, okay? And so loads are being things like external forces or maybe external torques or external moments, okay? And those are going to be applied on your structure to make it deform. And constraints are things that restrict its motion. And so you might have to fix your part in space or prevent it from displacing or things like that, okay? And so boundary conditions, they have a big impact on the results. And we'll spend a lot of time this semester talking about, how do you determine what boundary conditions to apply and how to actually apply them on your part, okay? And so in this image right here, what you have is some kind of crank. And then what it looks like is you have a force that's being applied here by these red arrows, and that's going to cause the crank to want to rotate. And then these, and these parts, these little arrows right here, that might be where it's fixed to something else. Okay. All right. And so, the last three steps that we went over, the boundary condition or the material properties, the meshing and the boundary conditions, those are all steps that you have to perform manually, and you have to make sure you get it right. Okay. And so the next two steps, these are parts that's handled underneath the computer. And so, for most practical cases, you don't have to worry about them. But we will dive a little bit into the theory into this class, and so these steps will make a little bit more sense later on. Okay. But the next step after you do all those things is to assemble what I call the global system or the global linear system. Okay. And so what your computer is doing underneath the hood is that it's, now that it's taken your mesh and it's taken your boundary conditions, it's constructing this gigantic system of linear equations, okay, and it's putting it in matrix form, right? And so here I have an image of a 5x5 system, but this is not nearly what it's going to be. And so, for any kind of practical problem, you're going to have a system of probably, hundreds of thousands or millions of equations and millions of unknowns, okay? And assembling that system is not a trivial thing. And so that's something that your computer is doing, okay? And the reason it does this is because computers are actually really good at solving linear equations, right? And then once you've assembled the system, the next part is to solve, right? And so this is, again, another part that the computer handles on its own. And so for most cases, you don't have to worry about this, but, we will be diving into the theory a little bit later in this class. And so I want to make you guys aware that, this is kind of part of the process. And, we'll do a few simple problems by hand just so that you can kind of, understand what it's doing underneath the hood. Okay. Right. And then the final step is to post-process. And so, after the simulation is done, all you have to do is just to look at your results. And so, the way that ANSYS is going to show you results is it's going to show you results in terms of a color contour plot, right? Almost like a heat map. And so what you're seeing here is a plot of the factor of safety, okay? And so what this simulation has done is that it's computed all the stresses and it's computed factors of safety throughout this entire part, okay? And so you can see in all the red parts here, they have a factor of safety of 7. And so those are really safe. But, for all the places where it's blue, you can see that the factor of safety is approaching 0. So I would be very concerned that that the part was going to fail in these locations. Okay, and this is something that you can predict with finite elements. And so you can not only predict whether your part will fail or not, but you can also predict where it's going to fail. And so these might be areas where you try to reinforce it with some additional additional material. Okay. Okay. So any questions on this so far? I know I went a little bit fast, and it's supposed to kind of feel like that, but I think once we start working with the software and once we start going through the theory, each of these steps are going to make a lot more sense. But what I want to do on this first lecture was just to highlight to you that there is a systematic process to doing these finite element simulations, and you want to make sure that you understand kind of what each step is and what you're trying to accomplish in each step. So that when you actually go to do it, it makes a lot more sense, and what you're trying to accomplish. Okay. All right. Question. All right. Question. So how is SolidWorks simulation compared to Catia? That's a great question. And so a lot of software packages nowadays, they're trying to kind of complete kind of the full package, and so they're trying to do the full simulation in CAD software. And so I don't actually have. I actually don't even have that much experience with SolidWorks simulation, and I actually wasn't even aware that Catia had its own simulation package too. And so I can't comment on it, and so I don't I don't know what they're actually doing under the hood, but it's definitely something I could look into, and and we can talk about later in the semester. Yeah. All right, and so we are going to learn some background information in this class, and so we're not just going to be playing with the software. And so and undoubtedly, the question that everyone asks, in this class is, why are we even bothering with the background knowledge, right? And so we're learning the background knowledge because even though finite elements is a powerful tool, it's just a tool, right? And so just like any tool that you have in your engineering toolbox, right? Whether it be a drill, whether it be like a saw, whether it be like a fancy laser cutter, right? All tools have limitations, and all tools have ways that they can be misused. Okay, and so it's important to understand the background knowledge because you need to understand what situations where finite elements are going to work well and what situations where it's not going to work well. Okay, because the reality is, there are going to be situations where finite elements is not going to be the right approach to take to a problem. Okay, and understanding the theory and understanding how it works will help you, understand these situations, and it'll also help you understand, if you are running into problems with finite elements, how do you actually debug those problems? Okay, because it's one thing to understand or to learn what buttons to click in the software and how to produce pretty plots. It's another thing to actually use it with purpose. It's another thing to use it with actual theory to back it up, because you're going to avoid situations where you get wrong results, and for when you're struggling, you're going to know what to do. Okay, and once you leave this class, what I want you guys to feel like you guys are experts in finite elements. And as an expert, there's a responsibility that you have to not only understand your tools, but also be honest about its limitations. Okay, and so we're gonna dive into some of the background knowledge so that you can have that information, so that you know when it's best to use finite elements and when it's not. Okay, and so just to give an example, let me talk about a veterinarian. Okay, and so a vet, they need to know a lot of the procedural skills, right? And so they need to know, how to give a shot to an animal, how to take a blood sample, how to check their eyes and their ears. Okay, and so all of that is important to know for a vet. But you also kind of expect your vet to know why they're doing all these things, right? And so when you go to a vet and you take your dog or your cat there, and they say, oh, we want to give your pet all these shots. You expect them to really understand why, right? You don't want your vet to be injecting your cat, just because, oh, I saw a YouTube video on it, right? And so I thought it would be the right thing to do. Right? You expect them to have, a deep conceptual knowledge and deep understanding of why they're doing the way they're doing, so that they can justify to you that it's actually a good thing for your pet. Right. And so it's the same thing with finite elements, right? And so not only do you need to know what buttons to push in the software, you need to understand why you're doing it so that you can actually, so that people can actually trust your results. Okay. All right. And so the last thing I want to cover is why ANSYS. Okay. And so, ANSYS is just one of the many finite element softwares out there. So there's a lot. And so, there's an argument to be made is, why don't we learn multiple softwares, right? And so first of all, we're learning multiple softwares. I think there's a lot of I think overhead associated with that, and so it's kind of a lot to cover in one class. But no matter what software that you're learning, there's a lot of transferable skills, right? And so no matter if you're using ANSYS or using Abacus or you're using SolidWorks simulation, you're going to use the same general steps, and you're going to have the same general concepts, the same general knowledge that you can apply to any finite element software, right? And so we're going to focus on ANSYS just because it's, first of all, it's one of the most common ones used out there, but I think also it serves as kind of a good test bed where if you understand ANSYS, you can kind of take that knowledge and apply it to other things. Okay. And if you want me to keep it real and you want to know the real reason we're using ANSYS is that ANSYS has a free version. And so there's a free student version that you can download onto your own personal machines. And that just makes it a lot more practical because then, there's a lot less licensing that we have to deal with, a lot less companies that we have to talk to. And so, ANSYS makes it easy, and they have a good, marketing team going where they said, let's give them a taste. Let's give them a taste of the free version so that, so that they'll want to pay for the professional one once they get a real job. Right? Okay. and so I want to save this one for later. And so, we kind of already talked about a lot for this too, where, when you're done with your finite elements, you really need to learn, you really need to know how to verify and interpret the results well, because that's where you make your money as as an engineer. But, I think I'll save kind of the deeper discussion for this later on in the semester. Right? All right. Any questions on just an introduction to the course before we jump into the syllabus? Okay. All right, and so let's go over the syllabus, right? And so if you have the syllabus in front of you, you can download the PDF from the course website. You can follow along, or you can just look at the lecture slides, because that's kind of what I have here. Okay, so let's talk COVID procedures first. And so I know we're virtual right now, but this class is planned to be in person, right? And so since we are meeting in person, and since COVID is still a thing, right? And so we need to make sure that we're all on the same page here on COVID procedures. Okay. Because even if you're vaccinated, there's still a risk that's out there that the virus can spread, not only to you, but to your loved ones that you're going home with. Okay, so we want to make sure we're safe as possible, right? And so the first precaution that we're going to take is social distancing, right? And so at this point, we've been at this for a year and a half, and so I don't think we need to explain why that's important. But I think the nice thing about this is that we're blessed with kind of one of the bigger rooms in our school. Okay, and so I think the computer stations themselves are decently spread apart. But even then, when you come into the classroom, if you can kind of spread out as much as possible, maybe don't get a workstation that's right next to someone else. Maybe try to put one extra space in between you and them. That would help out a lot. Okay. And so I think, I think with 40 people, I think it's inevitable that people are going to have to sit next to each other, but try to limit it as much as possible. Okay. All right. And so the next thing is, you have to wear a face covering inside the classroom. And so it has to cover both your nose and your mouth. Okay. So please make sure to have that on at all times in the classroom. Right. And so that's just to make sure that, it has less to do with, preventing particles from entering you, but just making sure that all the particles and gross mouth stuff that comes out of your mouth and your nose, that the mask catches that before it gets out into the air, right? And so the best way to kind of prevent the spread of COVID is to make sure that, we prevent as many gross mouth, nose stuff from entering the air as possible. And that's what the face covering is supposed to do. Okay. All right, and so if you have to cough or sneeze, even though you're going to have your face covering on, if you can do that into your elbow or into your tissue or to cover your mouth, I think that would be, that would help a lot. Okay. And also, the school is going to give us cleaning supplies as well. Okay. And so I'm going to do this too. And so, I know that, for you guys, it's your schedule might be tight, and so you have to run right after class. It's no big deal, but if you can help me out with this, it'll help me a lot, because it's and so after you're done using your desk and your chair, if you can wipe it down with the cleaning materials, it would help me out a lot. And definitely feel free to do this before class too, right? And so I'm going to be doing this. I'm going to be going through the class and wiping stuff down, but if you can do it, it would help me out a bunch too. Okay. And so I've been telling people, use gym policy for this, right? And so if you're at the gym, and you have Sweaty McGee that's kind of working on a machine before you, right? You would really appreciate it if he wipes it down kind of before you get on it too, right? And so, kind of use that same policy, especially since we're going to be using the computers in the lab. And so if you can wipe down the mouse and the keyboard, with the cleaning materials, it would really help out a lot. Okay. All right. So any questions on COVID procedures? So the plan is to be in person for most of the semester. And so this is kind of a unique thing just because I have some symptoms, but and so if I don't say anything, you can assume that we're meeting in person. Yeah. And so if we have to go virtual, either I'm exhibiting symptoms or something happens, then I will let you know. Right. But if I don't mention anything, then you can assume that we're meeting in person.
Professor, what do we do if we think we have it? Like if we were to get symptoms, would you have recorded lectures for us to look at, or?
Yeah, that's a great question. I think that's a good one to answer. And so unfortunately, we don't have the best setup in the classrooms to do like a good virtual teaching. But I will be turning on the webcam in the classroom. And so if you are feeling symptoms or if you are feeling sick, I am going to ask you to stay home. But of course it's up to how you feel as well. And so, if you feel like you're good to come to the classroom, of course you're welcome. But if you feel like you're sick, then, please stay home. So I'll be turning on the webcam in the lecture. And so, just at the very least that you can hear me. I don't think it'll be easy to view the board. But I think, a lot of the lectures that we're going to be doing, we're going to be working directly with the software. And so the nice thing is that, a lot of times I'll just be working at the workstation anyway. And so I'll be turning on Zoom for that, and I'll be recording that so you can view it at home as well. Yeah.
So would you have lecture notes as well if we needed them?
Yes. I'll be posting all my lecture notes. And so I'll be posting that the week before the lectures as well. And so, you can follow along on the lecture notes as I go. And even for the lectures where I'm going to be, writing on the board, I usually follow the lecture notes really closely. And so, I write those lecture notes as almost like a script for me to go over in the classroom. And so you can just follow along on those lecture notes and kind of just listen to what I'm saying. Yeah.
Excuse me.
Yeah.
In case you ask us to go virtual again, would we still be able to access the classroom for the software?
Oh yeah, absolutely. And so actually, you can actually be in the classroom right now. And so if I have to go virtual, you're definitely welcome to use the classroom because we have it reserved for explicitly for this class. And so, if I have to be on Zoom for whatever reason, then you can be in the classroom physically and use the software from there or just watch the lecture from there. Yeah.
All right. Thank you.
All right. Any other questions on COVID stuff?
I had one question about the classroom.
Sure.
Do you know if it's reserved for other classes before and after our class?
Yeah, that's a good question. I don't know what the schedule is like for this semester. Usually it is for a normal semester. But with that said, I think there's like maybe 50 computers in the room or something, or something in the high 40s. And so even if there is a classroom going on, or class going on, usually if you go into the back row of the class, you can use it, as long as you're quiet, of course, and you don't disturb anyone.
Gotcha.
So usually, when I teach this class in person, there's always people in the back working on, other stuff. And, I don't mind them being there at all because it's one of the best places to use Ansys. So I think as long as you're quiet, as long as the instructor's okay with it, I think there's no problems. Yeah.
Okay. Thank you.
Oh, question in the chat. Question. So who will we talk to open the classroom if it's locked? Yeah. So if it's locked, usually, they probably don't want you being in there for some reason. And so if it's locked, maybe ask someone in the mechanical engineering office. And so if you go to the office on the first floor of engineering, someone in there should be able to open it for you. Yeah. Yeah, but I think they are going to be probably a little bit more strict with the hours, and so they might close it, probably maybe right after this class is done, and so right after 7 p.m. they might close it just for kind of safety reasons. Yeah. Oh, question.
Yeah. For the ANSI, when it comes to saving our work, what would be recommended? Saving it through a cloud, and then like we can take it with us, or have a USB handy? Yeah.
That's a good question. Yeah, if you have a USB flash drive, that would be, I think, the most convenient. But also saving it to the cloud, I think, would work too, because yeah, the computers in the classrooms, they don't have dedicated storage for you. And so if you are going to be working on the projects or working on the assignments in class, you need to be able to save it out. And so yeah, if you have a flash drive or if you have cloud storage, then that either of those things work. But yeah, make sure you save your work, otherwise it's you won't be able to retrieve it. All right, so let's talk about office hours. And so here are my office hours for the semester. And so, normally I will be physically in my office. And so my office is going to be CS 526. Okay. But, because I know people might be, in and out with COVID and stuff like that. And I am teaching one virtual section this semester too. And so I'm going to have a Zoom component to my office hours as well. Okay. And so if you're on campus and you want to come to my office, that's great. I'll be there. But if you find it more convenient, then you can talk to me over Zoom as well. Okay, and you can find the links for all the office hours from the course website. Okay. And so these are the times that I have, and so I always try to spread these out so that people can find at least one time that works for them. But I know that inevitably there's going to be some of you where none of these times work, right? And so if none of these times work, please just if you want to talk to me, just send me an email. I'd be happy to set up a session just for us to talk. Okay, whether it be through Zoom or you can come to my office as well. So whichever kind of works the best for you. All right, so here are the course level learning objectives. And so these are, we'll have our learning objectives kind of on a lecture by lecture basis, but these are the learning objectives that I have for the entire course, okay? And so, my goal for this is that by the end of the course, you should be able to look at this list of 4 things and you should be able to say, yeah, I can do all these things, okay? All right, so let's talk deliverables now. And so there's 7 assignments that are planned, okay? So most of these are gonna be ANSYS activities, right? And so they're gonna be basically labs that we're gonna be doing in ANSYS, where I teach you either a new feature of the software or we get some practice in ANSYS, and you're gonna have to return, you're basically gonna have to return a report back to me, okay? There's going to be one midterm exam, and so the midterm exam is going to cover a lot of the finite element theory that we're going to go over, okay? There's going to be one midterm project, okay, and one final project, right? And so this is a little bit different from how I've taught this in the past. And so in the past, I've done multiple midterm exams. So this time I'm going to try a midterm project because a lot of the feedback that I've gotten from this class, in the past that, you guys want to focus a lot more on the software. You want to focus on ANSYS. And so, I want to have kind of a midterm project to kind of, let you kind of flex your ANSYS muscles and to really work on something interesting, before the final project. Okay. All right. And so the lowest homework assignment will be dropped just because I know things can get crazy during the semester. And so I want to give you guys some flexibility, but please do them all. Okay. And so the midterm exam, it's not going to be cumulative. And so actually, I think, the midterm exam is not going to cover that much here. And so it might be like 4 or 5 weeks worth of material. And it's not going to cover any of the ANSYS stuff. It's going to be just the theory. But, we'll kind of cross that bridge when we get there. Okay. And here are all the dates that are planned for the project due dates and also the midterm exam. Okay. And so what you'll notice for the final report date, usually for a midterms, I try to be flexible with the dates. And so, if you guys need more time for this, I usually don't mind pushing these back a little bit. But for the final report, this is the absolute last date that I can have this due. Okay, because the university makes us finish grading before Christmas. And you guys are one of 4 different classes that I have that have final projects. And so I need that last week to really hunker down and grade everything. And so, I can't really have it due after this because otherwise I'm not going to have enough time to grade everything. Okay. Any questions on this so far? Okay. All right, and so here's the course grade breakdown, okay? And so the homework's gonna be worth 10%. Each of the midterm, the project, and the exam are gonna be worth 25% each, and then the final project's gonna be worth 40%, okay? And then the course credit breakdown is shown below, and so I think this is pretty standard, okay? And so, a lot of times what I'll do at the end of the semester is I will, I'll make some adjustments to your grade. It's always gonna be a positive adjustment, and so I'm never gonna bring you down, okay? But I usually do those kind of at the end, okay? And so, even though we have this this breakdown here, it's not the final one, and so there's going to be some adjustments at the end usually. Okay. Question: so do I recommend a textbook for this course? Yes. So there is a textbook that's recommended, and we'll get to it in a little bit. Yeah. All right, and so actually, perfect timing. So here is the textbook, right? And so, these textbooks aren't required. And so I'm never going to require a textbook for any of my courses, just because I feel like the textbook industry is run by the mafia and they, prices are too fucking high for what it is. And so, you don't need to buy any of these textbooks. But, they are good references. And I would say especially the second one. And so the second one is actually a book that I just picked up this summer. And so it's actually really good. And so it's it has a lot of really cool examples that's specifically in ANSYS, and it has a lot of pictures that show you, where you need to click in the software. So it's a really great tool. It's a really good textbook, and it actually has a website that's that goes along with it, where you can download all of the projects for free, actually, too. Okay, and so I have the 2020 version here, but I think the 2021 version just came out, and so get whichever version that you can. Okay. And if you can find these textbooks for cheap, that's always a good thing. And if you can find an even cheaper version, sailing on the high seas, then that's and I would recommend that as well, because textbooks are expensive and schooling is expensive, and whenever you can save some costs, I think it can go a long way. All right, so course website, and so this is I think third semester or fourth semester or something that we've used Canvas, and so hopefully all of you guys are used to it. But my policy with the course website is that any content that I produce for the class is going to be posted on the website. Okay, so any kind of lecture notes, homework assignments, solutions, study guides, software tutorials, whatever, all of it is going to be on the website. Okay, actually, hang on. My cat was begging for food, and so I had to tell my fiance to not feed her. Okay, and so announcements will also be made through Canvas, and those will be automatically emailed to you, right? And so as a lot of you guys have seen already, okay. And I've already made a Discord. I've made a Discord server for the class as well. Okay, and so the Discord server, this is something that I started from the virtual teaching, but I really like it. I think it's something that's really nice, because it's my idea with the Discord server is that it gives you a chance, or it gives you a place where you can interact with your classmates, in a virtual setting, right? And so, I know we'll have the classroom this semester where you can talk and meet with your classmates and debug issues, but I think it's nice to have the virtual space as well. Okay, and so join the Discord server if you haven't already. It's not a requirement, but I think it'll be really helpful. Okay. And here's an important note. And so, I was really lax with this in past semesters, but in the past semester, it kind of got out of hand because people were kind of messaging me a lot. And so you can message me directly on Discord, but please only save this for emergencies, right? And so, I've gotten a lot of spam over the last couple of semesters, and stuff related to the class, but also stuff that's not related to the class. And I kind of just have to put some boundaries there, because it kind of got a little bit out of hand. Yeah. And so, if you have a question about the class, please use the Discord server. And so there's a questions channel on the Discord server where you can, input some questions. And that's great because, a lot of times, you're not the only one that has that question. And so if you ask it there, then, everyone can benefit from the response. Okay. But if it's a private matter, then you can please try emailing me first, before you send me a direct message. Okay. All right, questions. So are the in-class exercises and activities from the textbook? They are not. And so I make a lot of my exercises on my own. And so I think that's nice, because then you have the textbook exercises to kind of as kind of a worked example, but you also have kind of a different look from what we work on in the class. And so a lot of the in-class examples and exercises, they're going to be of my own creation. Yeah. But I like that just so that you have a lot of different examples that you can look at for how to use the software. Okay. All right, course policies, and so late homeworks, and so I do accept late homeworks, just because I know stuff happens, and it's hard to stay on top of all the due dates. And so if you're going to be late on an assignment, I don't want you to give up, and so I do still want you to turn it in. But because it's late, I do have to dock some points. Okay. And so each day that it's late, I have to dock 10%. Okay. And if the submission is closed on Canvas, then you can just email it to me directly. Okay. Regrades, you can request regrades. And so I make mistakes on grading, just like any other human. Okay. And so if you notice that I made a mistake on your grades, then please let me know. But please try to be timely about this. So, try to do it within a week after I return it to you. Okay. And if you're emailing me about the class, then, please make sure to include EGME 410 in the subject line, right? And so I'm teaching 4 different classes this semester. And so it really helps me out a lot if I know ahead of time, what your question is about. So please make sure to do that. And I'll promise you a prompt response. Okay. Question. And so do I post virtual recordings when we can't meet in person? Yes. You know, when we do start to meet in person, I am gonna use the webcam that's inside the classroom to record sessions. The only thing is that it doesn't I don't think it has a good view of the whiteboard, but you will be able to hear what I'm saying. Yeah. Mhm. My cat is going crazy right now because she thinks she's hungry. All right, graduate credit. And so this semester is a little bit unique because there is a graduate finite element class that's being offered as well. And so that's EGME 540. If you are a graduate student, I do recommend that you take EGME 540 instead of 410. But you know, you don't have to. Okay. And so 540 it's going to focus a lot more on the software, and we're going to do a lot more advanced stuff with ANSYS in 540. But you know, if you don't feel comfortable with it and you feel more comfortable in 410, then you know, you feel free to do that. Okay. The only thing I ask is that you don't enroll in both 410 and 540. Okay, because there's going to be a lot of repeat content in between the classes, and I think, you know, it'd be kind of a waste to kind of, you know, use two of your class slots for, you know, for kind of almost the same class. Okay. And so 540 is definitely more geared towards, you know, to be more useful for grad students. And so, you know, especially if you're working right now, I think 540 will be a lot more interesting to you. Okay. But if you are a graduate student and you plan to stick with 410, you know, there is a requirement that you have to complete an extra assignment in order to get credit for it. Okay. And so I don't know what that's going to be yet. And so I'll share details about that later on in the semester. Okay. And so if you're a graduate student or if you're an undergrad and you plan to take this for graduate credit, then please let me know as soon as possible so that we can sign the form and I can start thinking of the graduate assignment to give to you guys. Okay. Okay. So any questions on this so far? Okay. All right, academic dishonesty. And so I will say that, you know, for an elective class like this, I think usually this is less of an issue, but you know, it's something that we have to talk about, right? And so, you know, our department, we take a pretty hard stance against academic dishonesty, okay? And so academic dishonesty of any kind, you know, it will result in at least a 0 for that assignment. But if it's on something major like an exam or a project, then, you know, it can result in an F for the course. And, you know, it's something that I've had to do in a lot of my courses, you know, over the past couple of years, and it's not pleasant. Okay. I know it's a pretty hardline stance, and the punishment is harsh, but, you know, it's you know, it kind of is what it has to be, right? But I will say that, you know, the reason I have this hardline stance is, you know, I most of all, what I want from you guys from this class is I want you guys to take away something positive, right? And so I want you to learn something. And so, you know, I really feel that my role here as a professor, as an instructor, is to, you know, teach you guys skills and to, you know, and to give you something positive that you can take to your professional life, right? And so if you cheat, you know, if you copy from someone or you get someone else to do your work, you know, you're essentially you're not getting that benefit, okay? And so, you know, I don't really see myself as someone that's a judge, right? I don't see myself as a gatekeeper. I don't think it's my job to really judge about whether, you know, whether, you know, you're going to be a good engineer or not, even though I think some faculty kind of think that's what their role is. My job here is to support your learning and to make sure that you pick up the skills and you pick up the knowledge that you need to succeed professionally. Okay. That's my role. It's not to judge you. It's not to criticize you. It's to help you. It's to support you. Okay. And so at any time this semester, if you feel like you're really struggling in the course, you know, whether it be, you know, you have just a lot of stuff going on in your life, or, you know, the content is not really making any sense to you, please reach out to me. Okay. And I promise you that I'm not going to judge you. I'm not going to criticize you or anything like that. You know, I'm just going to say, okay, you know, I understand what you're going through, and let's come up with a plan to kind of get you back on track, and let's see how I can help you as best as possible. Okay. Because at the end of the day, you know, I succeed when you guys succeed, right? And so, you know, please come to me, because if you resort to cheating, you know, and I catch you, you know, there's really nothing I can do at that point, because, you know, our department has very strict policies on that. But if you come to me and you talk to me, then, we can work something out where, I can get you back to where you need to be in the course. Okay. And even if it's like, literally 10 minutes before the exam or 10 minutes before a project is due, you say, hey, professor, or hey, Dr. Tran, I'm really struggling with this. I don't think I can get this in on time, or don't think I'd be ready. Can I get an extension? Can we work something out? And I'm more than happy to work something out for you, even those situations. Okay. I've done that in the past for a lot of students, and I much rather have that than find out after you turn in an exam that you cheated on something. Okay. And so please just talk to me, and I promise I'll do everything I can to help you. Okay, and with that, we've come to the end of the first lecture, right? And so the last thing I want to talk to you about is our first homework assignment. It's not really a homework assignment, it's just a homework task. And so, just send me an email to introduce yourself, okay? And so I always really like to get to know all my students and to really, know where you guys are coming from and understand what you guys expect to get out of this course. And so please, just send me an email, right? And so make sure you include your name, your year, and your major, okay? And I have some questions here to get you started, but you don't have to answer these questions. They're just kind of, conversation starters, okay? And so, what I'm particularly interested in is questions 2 and 3, okay? And so if you have, something specific that you want to get out of this course, or you have some worries or concerns about this course as well, I want to hear those things so that, I can adjust the course based on what you guys are feeling, okay? Because every time, this will actually be my 4th time teaching this course, but, every time I teach this course, it's always different. And a big reason why it's different is because, the group of students is different every time, right? So you guys are looking for different things. You have different things that you're worried about. And I always want to make the adjustments to make sure that this class works the best for as many people as possible, okay? And so please be honest with me with these things, because, I really want to make this, class work, okay? And so if you can send me your introduction emails by Friday, then I can make sure that you get full credit for it. And then don't forget to put EGME 410 in the subject line, so I know what class you're in, okay? Okay, so any other questions before we end for today?
I have you for EGME 441. Do I have to do this just once?
Yeah, you can just do it just once. Yeah.
Okay, cool.
All right, question. So does the software run on Mac? It does not. It is a Windows only software. Yeah. And so if you have a Mac machine, you'll probably have to use the computers in the lab, or you can use the virtual computing labs. And so there's a way for you to access the computers remotely, and I'll put out instructions on how to do that later today as well. Yeah. All right. Any other questions before we wrap it up for today?
Just you said that you would let us know about Thursday being in class, or
yes, yeah. So I was actually expecting to get my test results today, but I guess not. So I'll probably get my test results tomorrow. And so if it's negative, then I'll email everyone. Then I'll say that we're going to meet in person. Yeah. All right, question. So if I'm enrolled in 540, should I drop 410? Yes. Yeah. So I would strongly prefer that you only enroll in one or the other. And so it's up to you which one you take. And so 540 is kind of the graduate version, and 410 is gonna be the undergraduate one. And so one of the big differences is, I say 540. We're not really going to get into the theory all that much, but whereas 410 we are going to do a little bit. And so, and 540 is going to be a little bit more advanced. And so, you can kind of choose which one you feel more comfortable with. Yeah. You can either boot camp Windows or buy Parallels. Yeah, you can dual boot your Mac as well. But we have options that you can do, so you don't have to do that, because ANSYS itself is kind of a big program that takes a lot of space. Yeah. Question. So for the midterm project, is going to be group or solo? I haven't decided yet, and so I'm leaning towards have it being a solo project, because your final project will also be solo, or it might be done in pairs. And so I like to try to keep consistency in the assignments, and so I'm leaning towards kind of a solo project for the midterm one, but we'll see. And so we'll once I get a better idea of what I want to do for the project, then I'll let you guys know. Yeah. All right. Any other questions before we wrap it up? All right, question. So if it's solo, can you get help from other students? Absolutely, yes. And so please, I absolutely encourage you guys to work together on the assignments and on the projects. Just don't copy each other. That's the only thing, right? There's a lot of benefits from working collaboratively with other people on learning stuff. But in order for that to work, everyone has to contribute equally to that arrangement, right? And so if one person is doing the work while everyone else just has pom-poms just cheering them on, that doesn't really work, right? And so, absolutely you can work with other students, but make sure that everyone's kind of contributing, or everyone's trying to work through the project as honestly as they can. Yeah. All right, question: is the library open to practice more if, say, the class, or is there a class in our classroom? So actually, yeah. So someone asked about this earlier, that you can use the computers in the lab room when it's not our lab time, but just be a little bit, but just be considerate if there is a class going on. But usually there's enough computers in there so that maybe about 5 or 6 of you can work on in the back. I don't think the software is installed in the library because it's kind of a very specialized software, and so I don't think it's installed there, at least not to my knowledge. Yeah. All right. Cool. And so that's all I had planned for today. And so, thank you guys again for being flexible and meeting on virtually online. And hopefully on Thursday we can come back. But have a great evening, everyone. Thank you again for tuning in, and I'll see you guys on Thursday.
Excuse me, I have another quick question.
Sure. What's up?
Do you happen to know if the computers in the CS building, the computer lab, is open?
It should be open. Yeah, because technically this class is supposed to be there right now, and so yeah, it should be open. I don't know what time they close. I don't know if there's another class that's going to take place at 7 p.m. But it should be open right now.
Not the classroom, but the computer lab. I think it's on the 2nd floor.
Oh, the 2nd floor one. Oh, that I'm not sure. I haven't had a chance to look, but yeah. But it should be, because I think the plan is for people to be back, and so I think it should be open. Yeah.
Okay. Thank you.
Yep. Yeah. Thanks, guys.
Professor, if we're on the wait list, how do we add the class officially?
So usually what I do is I just make the enrollment capacity bigger, and so I usually do that on the 2nd week. Partially because people like to move around on the 1st week, and also partially because our admins don't like doing stuff on the 1st week, just because they're kind of swamped with a lot of other stuff, and so usually I don't bug them until the 2nd week. Yeah.
Okay, so we would be automatically enrolled, or there's just like a section on our on the student center to click?
You'll be automatically enrolled. Yeah.
Alrighty. Cool. Thanks again, Dr. Tran.
Thanks. Yep. Thanks, guys. Have a good evening.
Thanks, Dr. Tran. We'll see you later.
Yep. See you guys later.
Thank you, Dr. Tran. Bye.
Thank you. See ya.
Yeah.
Yeah, so and so I know 410 is a prereq for 540, but it's not one that we're going to enforce, and so you're not going to be dropped from 540. Yep. Yeah, so biomechanics will be online tomorrow. Yeah. I'll send out the link again for the Zoom room. Yep. All right, I'll see you tomorrow.